Tonight, when it gets dark, step outside and look up. Count the stars in one small patch of sky. You have done this before, maybe as a child, maybe last summer. The sky felt permanent then. It felt like the one thing that does not change. Now imagine you count again and the number is wrong. One star is missing, not hidden by a cloud, not washed out by city lights, missing. There is a place where it should be, a small dark gap your eye keeps returning to, the way your tongue returns to a missing tooth. You check a star chart on your phone. The chart says the star is there. The sky says it is not. You would tell yourself it is nothing. A satellite passed. Your eyes are tired, and you would probably be right. Stars do not simply switch off. Everything we know about physics says a star cannot vanish quietly. It can explode, it can collapse, it can fade over billions of years, but it cannot just stop. So you go back inside. You forget about it. A week later, an amateur astronomer in another country posts 2 photographs of the same constellation taken 1 year apart. In the first photograph, there are 1,406 stars. In the second, there are 1,404. He asks if anyone can explain it. No one can. Then, an observatory in Chile runs a routine comparison of its sky surveys and finds 16 more. 16 points of light that were there and now are not. No explosions, no final flares, no debris. Each one simply absent, like a word deleted from a sentence. This is where the quiet part ends. Because stars are not decoration. Every human calendar began with them. Every ocean was crossed by them. Every probe we have ever launched finds its way by them. The stars are how we measure time, distance, direction, and our own place in the dark. They are the reference points of everything, and reference points are not supposed to disappear. In the next hour, we are going to take this seriously, step by step. What a star actually is, how stars are allowed to die, and how they are not. What it would mean, physically, for a star to go out ahead of schedule. What you would see from your backyard, what Earth would notice first, and how long we would have to notice it. And at the very end, we will look at one uncomfortable question that sits underneath all of it. If the stars started going out one by one, would it look like an accident? Or would it look like a pattern? Keep that question in mind. Look at the sky one more time before we begin. Count them while you can. Before we talk about stars going out, we should be honest about what a star is. Not the poetry, the machine. A star is a nuclear explosion that never ends, held together by its own weight. You take hydrogen, the simplest matter in the universe, and you gather enough of it in one place. Gravity squeezes the pile. The center heats up. At about 15 million degrees, hydrogen begins fusing into helium, and every second of that fusion releases more energy than every weapon humanity has ever built, combined. The explosion pushes outward. Gravity pulls inward. A star is the standoff between those two forces, and that standoff can hold for 10 billion years. Our sun burns 600 million tons of hydrogen every second. It has been doing this since before Earth existed. It will keep doing it long after everything you have ever touched has turned to dust. And here is the detail most people never hear. When sunlight lands on your face, that energy is ancient. A photon born in the sun's core spends roughly 100,000 years fighting its way to the surface before it escapes. The warmth you feel on a beach started its journey before the last ice age. Hold on to that idea. Light takes time. It is the most important fact in this entire story. The sunlight on your skin left the sun 8 minutes ago. The light of Sirius, the brightest star in the night sky, is 8.5 years old. The light of Polaris, the North Star, left home more than 4 centuries ago. The faintest stars you can see on a truly dark night sent their light while the pyramids were still new. All of it arrives at your eye in the same instant, and your brain calls it now. But it is not now. You have never seen the sky as it is. You have only ever seen the sky as it was. The night sky is not a window. It is an archive. Every star is a document from a different century, and every night the whole library opens above your head, pretending to be a single moment. Astronomers build their entire science on this. For them, distance is time. Point a telescope at something far enough away, and you're watching the early universe with your own eyes. The sky is the only place where the past is still physically visible, and we do not just look at it, we depend on it. For most of human history, the stars were the only reliable machine we had. Farmers planted when certain stars rose. Sailors crossed oceans with nothing but a horizon and a familiar constellation. The first calendars, the first maps, the first sense that the world had order at all came from the fact that the sky repeats. Even now, in the age of GPS, when a spacecraft needs to know its orientation in deep space, it does not ask a satellite. It photographs the stars and compares them to a catalog. Star trackers guided Apollo. They guide the probes we have sent past Pluto. The stars are still our navigation system of last resort, the one that is supposed to never go down. There is more. The stars did not just guide us, they made us. Hydrogen and helium came from the beginning of the universe, but almost everything else, the carbon in your skin, the calcium in your teeth, the oxygen in the breath you just took, was cooked inside stars and scattered when they died. The iron in your blood was forged in the core of a star that no longer exists. You are, in the most literal sense, assembled from stellar wreckage. So when we say a star went missing, understand what that sentence actually touches. Timekeeping, navigation, chemistry, history. The stars are not scenery above the world. They are the infrastructure underneath it, and this infrastructure has one flaw. It is never live. The archive is always out of date. If Polaris died tonight, nothing in your world would change. Not tonight, not this year, not this century. Its light would keep arriving, calm and steady, for more than 400 years. Ships would steer by it. Children would learn it. Poets would write about it. An entire civilization would keep trusting a star that no longer exists because the news of its death travels no faster than its light. The sky cannot warn you in real time. Whatever happens out there, you find out late. Years late, centuries late, sometimes so late that the thing you are looking at belongs to a different age of the universe entirely. Which leads to a question that sounds paranoid until you remember it is just physics. Tonight, thousands of stars will shine above your house, steady and familiar and reassuring. How many of them are already gone? Stars do die. That part is not a mystery. Astronomy has watched it happen thousands of times, and the deaths follow rules. If we want to recognize a wrong death, we first need to know what a right one looks like. How a star dies depends mostly on one thing: its starting mass. The smallest stars, the red dwarfs, barely burn at all. They sip their hydrogen so slowly that a red dwarf born at the beginning of the universe has used up only a fraction of its fuel. Their expected lifespan is measured in trillions of years. The universe is not even 14 billion years old, which means that in the entire history of everything, no red dwarf has ever died of old age. Their funerals are scheduled for a future so distant that the word future barely applies. A star like our Sun lives faster and dies bigger. In about 5 billion years, the Sun will run low on hydrogen in its core, and the balance we talked about, gravity versus explosion, will begin to slip. The core will contract, the outer layers will swell. The Sun will grow into a red giant so large it will swallow Mercury, then Venus, then probably the sky you are standing under. Eventually, it will shrug off its outer layers into space, a glowing shell of gas we call a planetary nebula, and what remains of the core will settle down as a white dwarf. A dead star, yes, but not a dark one. A white dwarf is a corpse that glows. It holds so much leftover heat that it will keep shining for billions of years, a nightlight that outlives its own solar system. The heavyweights die loudest of all. A star 10 or 20 times the mass of the Sun does not fade. It detonates. When its core runs out of fuel, it collapses in less than a second, and the rebound tears the star apart in a supernova, an explosion bright enough to outshine an entire galaxy of 100 billion stars. For weeks, a single dying star can be the brightest object in its corner of the universe. What survives is either a neutron star, a sphere the size of a city with the mass of a sun, or a black hole. Notice what all these endings have in common. They are loud or they are slow, and they always leave a receipt. A red dwarf takes trillions of years. A sun leaves a glowing shell and a white-hot core. A giant announces its death to half the galaxy and leaves a crater in space-time. In every version, there is evidence. Light, heat, debris, radiation, a remnant sitting exactly where the star used to be. Nature does not clean up after itself. Astronomers can point their instruments at the wreckage centuries later and reconstruct the whole event, the way investigators reconstruct a fire from ash patterns. There is one more ending worth mentioning, the quietest one physics allows. When a white dwarf finally radiates away all of its heat, it should become a black dwarf, a cold, dark, dead sphere drifting through space, invisible forever. It is a real prediction. It is also purely theoretical for a simple reason. Cooling takes so long that the universe has not existed long enough for even one black dwarf to form. The first true darkness of that kind is still trillions of years away. So this is the rule book. Stars can burn out, blow up, or collapse. Slowly, loudly, with evidence. What the rule book does not contain is a fourth option. There is no process in standard astrophysics by which a healthy, middle-aged star simply stops shining overnight and leaves nothing behind. No glow, no shell, no debris. Just an empty coordinate. For most of the 20th century, that fourth option was not even a question worth asking. The sky was permanent. Star catalogs were the most boring documents in science, updated for precision, never for absence. And one more thing, before we move on. Remember the archive. Every one of those deaths, the slow fades and the galaxy-bright explosions, reaches us only at the speed of light. Some of the stars in tonight's sky may have already finished dying. Their supernova may have already happened, centuries ago, and the flash is still on its way to your eyes, crossing the dark at 300,000 kilometers per second, carrying news that is already old. We accept all of that. It fits the rules. Deaths we have not seen yet are still deaths that follow the physics. The problem, and the reason this video exists, is that the sky has recently started breaking the rules. Because when astronomers finally did compare the old photographs with the new ones, they found empty coordinates. In 2009, in a spiral galaxy 22 million light-years away, astronomers were watching a star that should have been unmissable. It was a red supergiant, 25 times the mass of our Sun, the kind of star that ends its life in one of the brightest explosions in nature. And it was behaving strangely. Over a few months it flared, brightened by a factor of 1,000,000, and then, instead of exploding, it began to dim. By 2015, it was gone. Not dim. Gone. The Hubble Space Telescope looked at the exact spot. Optical light. Gone. A faint whisper of infrared remained, fading, and then, effectively, nothing. The star has a name, or had one, N6946-BH1. It sits, or sat, in a galaxy nicknamed the Fireworks Galaxy because it produces more supernovas than almost any galaxy we know. A place famous for loud deaths delivered a silent one. The leading explanation is called a failed supernova. The theory goes like this. The core collapsed, as expected, but the explosion stalled. Instead of blowing itself apart, the star swallowed its own detonation, and the black hole forming at its center simply ate the rest of the star from the inside. No fireworks, a flicker, and then darkness, and a black hole sitting where a giant used to shine. Understand what that means? Modern astrophysics accepts as a real documented possibility that a massive star can disappear from the sky without a visible explosion. The receipt we talked about, the evidence every death is supposed to leave can be reduced to almost nothing. Astronomers found this event because they happened to be watching that one star closely. So the obvious next question was uncomfortable. How many stars are we not watching closely? A few years later, a project set out to answer exactly that. It is called VASCO, Vanishing and Appearing Sources During a Century of Observations. The idea is beautifully simple. Take the old photographic plates of the sky, some of them from the 1950s, and compare them, point by point, with modern digital surveys. Look for anything that was there then and is not there now. They expected errors. Dust on the plates, film defects, asteroids photobombing, satellites streaking through frames. They filtered all of that out. And after the filtering, there was a remainder, about 100 points of light present in the old sky, absent in the new one. 100 candidates for something the rulebook says should be almost impossible. Sources of light that existed and then did not, with no recorded explosion, no visible remnant, and no accepted explanation that covers all of them. Most of these will eventually turn out to be something ordinary, a flaring star caught at its brightest. An instrument artifact no one has identified yet. Science is patient with its anomalies, and it should be. But every astronomer who works on this will tell you the same thing. Some of the disappearances are hard. The plates are clean. The object was real. And the sky at that coordinate is now empty. There is a third case worth knowing because it shows how strange a star can act while still existing. In 2015, a star called KIC 846-2852, better known as Tabby's star, was caught dimming in ways no one had ever seen. Not the neat, regular dip of a planet passing in front of it, but chaotic plunges, up to 22% of its light, gone, then back, then gone again. For months, serious institutions had to entertain serious questions about what could block a fifth of a star. The most likely answer today is a cloud of fine dust. But for a while, the most studied star in the galaxy was a star that behaved as if something enormous were passing between it and us. Put these three files side by side, a giant that swallowed its own death and left the sky dark. About 100 candidate sources that appeared in old survey data and were absent from modern surveys. A star that flickered as if occluded by something we never saw. None of this is fiction. All of it is based on published astronomy, and some of it remains unresolved. Now, here is the part that should genuinely unsettle you, and it is not any single case. It is the method. We did not catch these disappearances happening. We caught them afterward, by accident, in the archives. The sky does not send alerts. For all of human history, we have assumed that if something dramatic happened up there, we would see it. A new star, a comet, an explosion, something added to the sky. We were never prepared for the opposite, something subtracted from it. Our telescopes watch a tiny fraction of the sky on any given night. The rest, the overwhelming majority of those thousands of visible stars and billions of faint ones, is photographed occasionally, checked rarely, and assumed to be permanent. If a star 300 light-years away had quietly gone out in the year 1800, would we know yet? Check the math. Its last light would still be on the road. The answer is no. We would be living under it tonight. Let us run the experiment honestly. Suppose it begins tonight. Somewhere in our own galaxy, a few hundred light-years away, stars start going out, one by one. Quietly. What actually changes on Earth, and when? The first answer is unsettling in its own way. Nothing changes. Nothing at all. The light already in transit keeps arriving. The sky above your house tonight would be indistinguishable from the sky last night. Your phone works, planes land, the sun rises. If stars within 500 light-years of us went dark this evening, Earth would learn about each one only when its last light arrived, years, decades, or centuries later, depending on distance. The news would be on its way the whole time. The first people to notice might not be governments at all. It could be an automated survey or an amateur astronomer comparing the same patch of sky night after night. There are hundreds of thousands of amateur astronomers on Earth, and they are the only large group of humans who still actually look at the sky night after night and compare it to what it was. Somebody photographing a favorite constellation from a backyard would develop the frame and find a hole. They would assume equipment failure. They always do at first. They would check the optics, reshoot, ask a friend across the ocean to confirm. And then a forum thread would appear with a title that sounds harmless, something like, "Has anyone else lost HD 219134?" Then the confirmations arrive and the professional surveys swing over, and this is where it stops being a curiosity. Because the moment one confirmed unexplained disappearance exists, every telescope on Earth has the same new job: finding the others. While astronomy is having its crisis, the practical world would feel the first pinpricks. Satellites keep themselves oriented by photographing stars and matching them against onboard catalogs. Star trackers are built into many spacecraft we fly, from weather satellites to deep space probes. A missing star does not blind them, it creates a mismatch. The tracker sees a sky that no longer agrees with its map, flags an error, switches to backup stars. Engineers would notice a rise in navigation faults, small at first, easy to patch. But the patch itself would be historic. For the first time, humans would be deleting stars from the catalogs, not adding them. And it would not only be our machines. Night-migrating birds steer by the stars. Indigo buntings learn the rotation of the sky around the pole star as chicks and use it as a compass for the rest of their lives. Seals track individual stars at sea. Even the humble dung beetle navigates by the glow of the Milky Way. The natural world has been using the sky as an instrument for 100 million years longer than we have. Erase enough points from that instrument, and something begins to drift in systems that have never failed before, migration lines bending, arrival dates slipping, and no biologist able to prove why. But the deepest impact would not be technical. It would be psychological, and it would grow with every confirmed loss. Every civilization we know of, without exception, built its sense of order on the sky. Calendars, harvests, gods, navigation, fate. The one shared human experience across every century and every continent is looking up at night and seeing the same fixed pattern our ancestors saw. The sky is our oldest proof that the universe is stable, that the rules hold, that tomorrow resembles today. Now imagine living in the decade when that proof starts developing holes. Imagine explaining to your child that the constellation in their bedtime book is out of date. Imagine the first religious movements built entirely around the gaps. Imagine checking each night the way people now check the news, whether the sky lost anything while you slept. The panic would not come from danger. Nothing is falling on anyone. It would come from something quieter and harder to treat. The suspicion that the background of reality is being edited, and that we do not know by what, and we do not know the order of the list. And there is one more detail, the one an astronomer would whisper last. We would be seeing these disappearances late, each one delayed by its own light travel time. A star 400 light-years away that we lose tonight actually went dark 4 centuries ago, which means the event, whatever it is not happening now. It already happened. We are not watching a crisis unfold. We are watching the paperwork arrive. So the reasonable next question is not about Earth at all. It is about geometry. If the stars are going out in some region of the sky, then that region has a shape. And a shape, plotted over time, has a direction. Before we ask what could do such a thing, we need to feel what it means to lose the stars themselves, not as scenery, as the only map we have ever had. For that, we need to go far from home. There is a reason sailors feared fog more than storms. A storm can sink you, but fog does something worse. It deletes the world. No coastline, no sun, no horizon. In fog, a crew with a perfect ship and full supplies can die simply because no direction means anything anymore. Now scale that up. Deep space is the purest emptiness there is. No landmarks, no up or down, no horizon. Between the stars there is nothing to stand on and nothing to measure against, except one thing: the stars themselves. Many spacecraft beyond Earth orbit use the stars as part of how they know their orientation. When a probe needs to know which way it is pointing, it photographs the star field and matches the pattern against a catalog in its memory. When navigators on the ground need to know where the probe is, they measure its radio signal and check it against a sky whose geometry they trust completely. The entire architecture of spaceflight rests on one assumption so basic nobody thinks to say it out loud: the reference points do not move, and the reference points do not disappear. Imagine a crewed ship somewhere far out, decades from home, even at incredible speed. The crew does not navigate by looking for Earth. That is the part movies get wrong. From even a few light years away, Earth is invisible, and the sun is just one more faint dot lost among thousands of identical faint dots. You do not find home by looking for home. You find home by knowing the pattern of everything else. The constellations are the address book. The sun's position is written in relation to them. Now give that crew our scenario. The stars are going out, one by one. The first loss is an inconvenience. The computer flags a mismatch between the sky and the catalog, marks the missing star as unreliable, and navigates by the rest. There are billions of stars. Losing one is like losing one word from a dictionary, but the losses continue, and the crew slowly discovers what navigators have always known, and passengers never think about. You do not need to lose the whole sky to be lost. You need to lose surprisingly little. Precision orientation rests on recognizable star patterns and trusted catalogs. Remove enough reference points in the wrong part of the sky, and confidence begins to degrade. Each course correction gets a little less certain. The uncertainty compounds, silently, the way rounding errors compound in a long calculation. No alarm sounds. The ship still flies. It simply becomes, degree by degree, less sure of where anything is. And then comes the moment that turns procedure into horror, the moment the crew stops trusting the catalog itself, because a catalog of stars is a photograph of the past, and their sky is being edited in the present. Every measurement now carries a question no instrument can answer. Is the difference between map and sky our error or another deletion? A ship in that condition is not lost the way a hiker is lost. A hiker can climb a hill and look around. This crew can see perfectly in every direction for trillions of kilometers. There is simply nothing left that they can fully believe. Fog made of clarity. If you want to know what that does to a human mind, you do not need a spaceship. Ask what happens to people in sensory deprivation, where the inputs do not stop but stop meaning anything. Orientation is not a luxury of travel. It is a load-bearing wall of sanity. We are built at a depth below argument to trust that the fixed points stay fixed. And here is the part that folds this back onto all of us, standing safely on Earth. We are that crew. Earth is a ship. It moves through the galaxy at 230 kilometers every second, carrying everything you love through a dark it did not choose, on a course it cannot change. The stars are not decoration on the voyage. They are the oldest reference grid on the bridge. They are how we know where we are, how fast we move, what the galaxy around us is doing, whether anything out there is changing. Lose them, and we do not stop moving. We keep going exactly as fast, exactly as blind. In 1977, we launched 2 golden records into the dark, bolted to the Voyager probes. On their covers, we engraved a map, our return address, drawn as lines from Earth to 14 pulsars, the most reliable lighthouses we knew. The idea was that anyone who found the record could invert the map and find us. Think about what our scenario does to that gesture. If the lighthouses themselves can be put out, the address stops working. Not because Earth moved, because the grid it was written in is being erased. A sky losing stars is not getting darker. That is the wrong way to say it. It is a map being deleted while everyone is still using it. Which brings us, finally, to the question we have been circling this entire time. Suppose it is real. Suppose the losses keep coming, and the astronomers plot each new gap on a chart of the galaxy, month after month, year after. Randomness has a look. So does its opposite. Scatter sand on a table, and your eye accepts it instantly. Arrange the same grains into a line, and something older than language sits up inside you. Humans are pattern detectors before we are anything else. It kept us alive for 1,000,000 years. It also means we see faces in clouds and messages in noise. So when astronomers in our scenario begin plotting the missing stars on a map of the galaxy, they would do it with every statistical safeguard science has ever invented, precisely because they know how badly every human being in the room wants the answer to be no. At first, the map would say nothing. 20 points scattered across an entire sky is scatter. 100 points is scatter with anxiety attached. The dread would not arrive as a shape. It would arrive as a number, a clustering coefficient drifting away from random sigma by sigma, month after month. Not a picture, a probability tightening. Then someone would notice the dates. Because the map has a time axis too. Each disappearance, corrected for light travel, has a true date. And if the true dates drift across the map in one consistent direction from one region toward another, then the word cluster quietly retires, and a worse word replaces it. Front. A front has an edge has a speed has a heading. This is not exotic science. It is the same arithmetic we use for weather systems and forest fires. Take the positions, take the corrected dates, and ask the only question left. Where is the edge? How fast does it move? And what lies ahead of it? Understand how much restraint would collapse the night that calculation is run. Astronomy would try every innocent explanation first, and the innocent explanations are real. Let us give them their due. It could be dust. Vast cold clouds drift between the stars, and a thick enough cloud can dim a star below sight. But dust dims gradually, reddens the light, blurs the edges. It looks like fog rolling in, and it does not advance in a tidy sequence. It could be the instruments. Whole catalogs have been haunted by software ghosts, but artifacts do not survive independent telescopes on different continents agreeing for years. And then there is the third explanation, the one that sits in the published literature with a straight face. Engineering. Since the 1960s, serious physicists have pointed out that a civilization far older than ours would need staggering amounts of energy, and the largest power source in any solar system is the star itself. Enclose a star in a swarm of collectors, and from outside, its visible light fades while its heat still leaks out as infrared. The idea is called a Dyson swarm, and it is not fiction. Real surveys have combed real sky data for exactly that signature, a star going dark in visible light while glowing warm in the infrared. So far, no confirmed detections. But the searches happened at real universities with real funding, because the logic is sound. A star that goes out without dying is either behind something, measured wrong, or being used. Now put yourself in the room in our scenario on the night the innocent explanations run out. The spectra show no dust. The instruments agree. The infrared check comes back, and some of the vanished stars are still warm. Warm and dark, like windows shuttered from the inside. At that point, the question stops being what is happening and becomes the question this entire hour has been walking toward. The front has a heading. Every heading points somewhere. And you already know, because you chose to watch a video with this title, what the map shows when the projection is drawn. The cone of the front, extended forward through the centuries, crosses a thin, ordinary band on the inner edge of one spiral arm. An unremarkable neighborhood containing an unremarkable yellow star, 100 light-years of quiet, and you. Let me be precise about what that would and would not mean, because precision is all that stands between fear and panic. It would not mean tomorrow. The distances are so vast that even a front moving fast by cosmic standards would take centuries to arrive, perhaps millennia. You would live your entire life, and your grandchildren would live theirs, under a sky that looks almost normal, minus a slowly growing list of absences. This is not an asteroid with a date. It is not a wave you can time. It would mean something stranger. It would mean living, permanently, inside a question. Every generation would inherit the map, redraw the edge, recompute the heading, and pass it down like a family debt. Some would insist the pattern is a statistical mirage, and they might be right. Some would build lives and religions and elections around it, and a small number of people in quiet institutions would work on the only practical question left. Do we say something, or do we go dark? That debate already exists, by the way, here in the real world, today. It has conference papers and decades of argument. Whether humanity should deliberately broadcast into the galaxy or listen silently is a genuine scientific controversy. Respected voices have warned against shouting into a forest when you do not know what hunts in it. Others answer that our radio and television have been leaking outward for more than a century, that the choice was made before we knew we were making it, and that the wavefront of our own noise already stretches nearly 100 light-years into the dark and keeps expanding. If a front of dying stars were aimed at us, that debate would become the most important argument our species has ever had. Silence or signal? Hide under the floorboards of physics or stand up and announce that this address is occupied. And this is where the science, honestly, ends. Everything you have heard so far is real or built directly on real physics. The dead surveys, the failed supernova, the vanished candidates, the Dyson searches, the navigation, the biology, the delay of light. All of it stands on published ground. What comes next does not. What comes next is a story. One version of how the last chapter might read, assembled from every real piece you now hold. Treat it as fiction because it is. But notice, before we cross the line, what you are already feeling. You have not seen a single star go out tonight, and some part of you is already listening to the sky differently. What follows is fiction. Every number before this point was real. The numbers after it are not. This is a thought experiment. One version of the last chapter told the way the evidence would tell it if the pattern were real. Somewhere in the files of this channel, we call it the archive hypothesis. It begins the way everything in this hour said it would begin, not with an invasion, with a catalog error. In the story, a survey telescope in Chile flags 11,000 dead stars in a single night. Not new deaths, old ones discovered all at once, the way you find water damage behind wallpaper. Some of those stars, the plates say, went dark centuries ago. Some, millennia. Nobody had ever assembled the full list before because nobody had ever asked the sky the right question. Plotted on a chart, the 11,000 are not scattered. They form lines, long, patient chains of darkness drawn across 9 billion years from the oldest burned-out giants at the galaxy's rim, inward, step by step, like footprints crossing snow. The intervals between deaths shrink as the lines advance. 1 million years between the first steps, centuries between the last. Whatever walked those lines was learning to walk faster. In the story, a graduate student does the arithmetic nobody wants to do. If every extinguished star is one step, the route has 11,000 steps, and 10,999 are already dark. She publishes the number quietly in a paper almost nobody reads. The counter, she writes, is at 1, and the last star on the line, the one still burning, is a red dwarf 14 light-years from Earth. Here the story pauses because honest fiction pauses where real physics would. Nothing arrives, no ships, no signals. The sky simply continues its accounting. The red dwarf shines. Years pass. The paper is forgotten, the way warnings written in careful language always are. Then Earth itself begins to notice things. Small things, each with a mundane explanation available, each explanation slightly too small to cover what it explains. A lunar relay photographs a shadow crossing the far side of the moon, kilometers wide, cast by nothing the cameras can find. Deep-sea hydrophones from Iceland to New Zealand record within a single hour one low tone the ocean has never carried, and its frequency matches the final radio pulse of 3 of the dying stars. For 90 seconds on a Tuesday in March, compass needles worldwide drift from north and settle, all of them on a patch of sky with no stars left in it. Dogs face it. Migrating birds refuse to cross it. Instruments built by humans and instincts 100 million years older agree about one direction, and it is the direction the lines point from. In the story, the models are rerun with the new data, and the conclusion is the one you already sense. The lines were never a feeding trail wandering the galaxy. The extinguished stars were chosen by position. Every route a ship, a signal, or a fleeing civilization could take away from this region of the arm passes one of them, and one by one, oldest and farthest first, those exits were closed. 11,000 dead stars are not a hunt, they are a fence, and Earth was never in the path of something. The path was drawn to Earth, not the target of an appetite, the address on a route, saved for last. Why last is the question the story never fully answers, and that is deliberate, because the honest versions of this story do not know. Perhaps small, loud, curious worlds are rare, and rare things are collected at the end. Perhaps the builder of fences finishes its perimeter before it enters. Perhaps we were simply far from where it started, and patience does the rest. What the story does answer is what humanity does with the knowledge, because that answer writes itself. We argue. For a generation, the fence is classified, then leaked, then denied, then confirmed, and the old debate, silence or signal, stops being theoretical. One camp buries transmitters, one camp builds them. And in the story, on an ordinary morning at 4:17 Universal Time, somebody ends the argument alone. A reply leaves this planet, 9 seconds long. Repeating the one frequency the ocean had been humming for months. The story never names who sent it. It only records that the transmission was received, because the response is immediate and it is not an arrival. Across the sky, in reverse order along the lines, the dead stars begin turning back on. First the red dwarf, 14 light-years out, then the next, then hundreds in a night. Light that should have taken decades and centuries to reach Earth arrives in hours, as if it had been waiting, folded, just outside the dark. Astronomers point every instrument on and off the planet at the returning light, and the spectra come back wrong. The signature matches no fusion process in any catalog. It is not the light of burning hydrogen. It is not the light of anything burning. It is the light of doors, opening. The final entry in the fictional file is not an image of ships, or a voice, or a face. It is a spectrum, printed and pinned to a wall in Chile, with one sentence written under it in pencil, in a hand nobody ever identified. They were never eating the stars. They were sealing them. And we just answered the knock. That is where the archive hypothesis ends, mid-sentence, the way real archives end, and there is a reason we keep it on file even though it is fiction. Not because we believe it, because it begins with the rules the real universe showed you tonight. The delay of light, the silence of failed supernovas, the blindness of a species that checks its own sky by accident, decades late, in old photographs. If something out there were patient and quiet and thorough, the first 11,000 chapters of its story would look exactly like nothing. That is the honest ending, so let us stand in it, one last time, under the real sky. Tonight, above your house, the stars will come out. Every one of them a running engine, every one of them a date stamp from a different century, every one of them an anchor point in the only map our species has ever owned. The universe we can actually verify is strange enough. Giants that vanish without a sound, about 100 candidate lights missing from old survey data, some still difficult to explain. Silent searches for shuttered suns conducted by serious people at serious institutions. You do not need the fiction to feel small tonight. The facts are sufficient, but when you look up, notice what your mind does now. It counts. Quietly, without your permission, some old sentinel behind your eyes runs down the bright points it knows and checks that each one is at its post. That reflex is 100,000 years old, and until tonight, you probably never caught it working. The sky is still full. The pattern, as far as anyone can prove, is still random. The counter, if there is one, has not moved, as far as we know. The archive continues.